Okay, so these are application problems. So what we're starting first with is London Eye. So London Eye is this big Ferris wheel in London, and it has 32 capsules and the diameter of 400 feet. That means from one end to the other end, it's going to be a distance of 400 feet. So that gives us the radius of 200 feet, right? So if we were actually to look at that, we want to know the distance you have to travel once you reach the highest point on there. So because we know that this is going to be a circle here, and this is the center, you get on here and the highest point is going to be up here. So we want to know this distance right here, which is going to be your arc length. So this is the S here, and we know the distance from here to here is going to be 400 feet. And so we know that the radius is going to be 200 feet, which is just this part. So if I want to know this distance, well, I also need to know if I'm using this formula, S equals to theta r, because it's not a rate. We're not going at a rate per second. They just want to know the distance of the arc length. So it's just a straight distance. So we want to know the arc length here. And so we know the angle halfway up there is going to be the angle of pi. And the radius we know is going to be 200 feet. And so the arc length is that we calculate those two and we end up with 628.319 feet. So we write the sentence because this is a word problem. The distance traveled is approximately 628 feet. And so that is the answer to the London Eye. Now, this one over here, the gears, I brought in a video so that you could see what's happening. So we have a small gear and we have a big gear, and they move together. So the main thing with the gears that you need to understand is that the distance of the arc length is going to be the same, but the angle being made with this one and the big one are going to be different. And so this is the reason why I'm talking to you. So here, see this notch? See how much it travels while I look at this notch and see how much it travels. So the distance is the same, but the angle is different. So I'm going to play it right now so that you could see. See how this is traveling? They're still covering the same length here, but the angle that this one's making is going to be a little bit bigger because if you notice right there, it made one full 360 or 2 pi circle, while this one started over here and didn't get it got only up to this part. So this one's going to make a smaller angle compared to this one because this one's bigger, but they're going to cover the same arc length because these things went together. They cover the same. So once around here is the distance of from here to there. So that's what this problem's asking. So if we're looking at this, the diagram below, the smaller gear has a radius of 5. So let's assume that this one here has a radius of 5 and it only travels 120 degrees. So the small one travels 120 degrees. How many degrees has the larger gear rotated? So we want to know the angle in which this one's rotating, and then we're going to round our answer to the nearest one. So here's the thing. We are talking about distance. It's not a rate. So we're just going to use the same formula. Theta is equal to S is equal to theta r. So it's the same thing that we're using from before because we are going to then, if we're using this formula, we need to use um, radians. This is telling us 120 degrees, but in order for us to use this, we have to convert it. So we need to convert 120 degrees. So we could actually, 120 is a reference of 60 degrees. So we know we could do it by counting of the 60 degrees. So this is 0, 1, 2, 3, and then 4. And so we know that this one here is going to be 4 pi over 6, which ends up being 2 pi over 3. So if I look at that, I could use that as my angle there. So when we talk about this, the smaller gear is going to be, and then we could just do the 5-inch one there is going to be theta r. So we are going to say the 5-inch, the smaller one, is going to be um, 2 pi over 3. Oops, sorry, let me erase that. Oops, 2 pi over 3. And when we calculated, that's going to be times 5 centimeters. And so we are going to have this to be 10 pi over 3 centimeters. So that is the length of the small one. So that's the arc length that that one's making. So that means that they're going to make the same distance, that the bigger one has to have the same arc length. So the larger gear, and we're going to say S12, is going to be theta r, is going to have the same arc length. And so we want to know the angle, but that one there is going to have 12.1 centimeters instead of 5. And so when we calculate that, 10 pi over 3 times 1 over 12.1 centimeters theta, then we are just going to calculate it. The centimeters and the centimeters are going to cancel, and so this is going to be in radians. So we are going to have this to be um, 10 pi over 36.3 radians. So the angle that what it's asking us is to round it to the nearest degree. So how many degrees is the larger gear? So I know when I use this formula, it's going to be in radians. So we actually want to change this back now, the 10 pi over 36.3. We are going to change this. This is radians, and we're going to put radians down here, 180 pi. I'm sorry, that's the other way around. It's going to be pi 180 degrees. And so the pi's are going to cancel. And so we are going to get 10 divided by about 49.58677 degrees. And so the answer here is the large gear rotates approximately 40. And does it say to the nearest degree? Yeah. So we're going to erase that. And so approximately 50 degrees. And so that's how we have that one there. Okay, and then here is the odometer one. So the odometer here, we have some information. They're telling us it's 17-inch rims, but the diameter of the tire is 25.7. So we're going to take the radius of the actual tire because that's what's going to be on the floor. So the radius here is going to be 12.85 inches. And then this one here, the radius of this tire is going to be 14.1 inches. And so now we know the radius of the bigger tire and the radius of the smaller tire. And so what we are trying to find here is if they're traveling after the tires have actually driven 1,000 miles, how many miles will the odometer report um, has been driven? So they've changed the tires from 17 to 19, so the tires are bigger. So we need to actually see whether the odometer is going to give us the right answer on there. So if we're traveling 1,000 miles on the regular 17-inch, we first need to figure out the miles in inches because when we calculate it has to be in inches there. So we're doing the 1,000 miles over 1, and then it's going to be 5280 feet in 1 mile. And then it's going to be 12 inches in 1 foot. And so the feet cancel, the miles cancel. And so we are going to get that this is going to be 63.36 inches. So that's how many inches are in 1,000 miles. So again, this is not a rate. So we're going to use this theta. Um, and this is going to be of the 17. So we're going to take the 63.360000 inches, And that's the actual um, arc length. And so we are going to then do the radius, which is going to come on here, and it's going to be 12.85 inches. And that's going to give us the angle there, right? So when we solve for this, this is going to cancel, and we're going to get 43739.3 radians. So this means that all I did was take the inches, divide it over here, and so that is your theta, and that's the angle that's being made in 1,000 miles. That's how many radians was made by a 17-inch tire. And so the angle is going to be, when we look at this, if we actually do now, when we calculate S19, of theta r, we are still, the angle is still going to be the same because it's going to spin there, but the arc length is going to be different. So we are going to put 19, and that's going to be 4930739.3 radians times the inches there. So it's going to be 14.1 inches. And we are just going to calculate. So 19 is going to be, hold on, let me put this down here, and that is going to be 69, 523.424.12 inches. And so that's going to be the arc length that is being made by the bigger tire. The angles are the same in this case because they're spinning at the same rate, but the arc length, because the tire is bigger, is going to cover this much distance, which is more than this smaller one. So when we do this, we're going to convert that because I need to know how many miles were actually covered here. So this is how many inches. So I need to change the inches back to miles. So this is going to be 4 inches, and this is going to be over 1, and this is going to be times 1 foot is going to be 12 inches, and we're going to get 1 mile is going to be 5280 feet. And so that's going to cancel. And when we multiply across and divide, we're going to get 1,097.28 miles. So what really happened is that the bigger tire covered more distance, which made more sense since it's spinning the same thing. It's covering more distance on there. So the odometer would read 1,097 more instead of 1,000. Okay, so there we